Hey everybody, this is Larry. This is me going over 132 pattern, the recent Leetcode daily challenge. It's a little bit late because I accidentally deleted the video by accident without uploading it. So anyway, hit. So I'm going to just do the explanation and kind of go through my thought process as I was solving it. Though it's not going to be one-to-one. Actually, I'm a little bit sad because this one I didn't have a lot of trouble with, but I had to prove it from beginning to end. I didn't like have an immediate knowing the answer, so it was kind of I thought it would have been interesting and really good to have seen it, but even for myself to kind of review what I did. But it is what it is. So I'm going to just explain this problem and let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and let's go over it. So the first, and I already have the code because I already wrote it, but the first thing to notice is that given an input, you could basically move a pointer. We're given I, J, and K, so we could choose J to be the pointer that we're moving. So this is J, and in a greedy kind of way, you could take the min element that came before it as I, right? So I is equal to min element to the left of J. And then what does that mean for K, right? K is just stuff that's to the end. Oops. Stuff that's all the way to the end. And then we just, if we keep everything here in a binary search tree or something like that, then we could just binary search or just regular search on a binary tree, which you can do in O log n times. Like for example, in Python, I would maybe use sorted list or something like that, right? And I could do this in a couple of minutes, and that would be n log n because it just takes like two search, or one search maybe even, like find the smallest number that's bigger than I, and then if that exists and it's less than J, then you have the answer, right? And because you maintain that in n log n times, it's gonna be n log n. So that's and n squared is trivial, as they say, so that's the n log n solution. How do we get the O of n solution? So I'm not gonna lie, when I first saw this, I think n log n was quote unquote standard for me, and I knew that one immediately. And if they didn't ask me about a linear solution, I might not have thought about it. I might have just been like, oh, okay, I'm done. And also during competitive programming, during a contest, I might be like, oh, n log n, this is good, right? But seeing that it's O of n, I'm like, okay, well, it's a little bit of a hint. That means that it's a couple of things. It's either greedy, or greedy is a big component of it. There's either, max, like one of the mono stacks, one of the queues, or some combination of stack or queue or something like that, because that's the only way you could keep it at O of n. And for me, this problem seems more like, you're processing stuff, you look at stuff in the past, so that to me seems like a stacky solution. And I took maybe not a long time, maybe like about 10 minutes, kind of go over the cases, like very slowly and very deliberately, because it was not intuitive for me, right? So basically what I did was that, okay, this is a little bit advanced because I actually already did it. But basically what I did was let's say I have a stack, I just have set a negative infinity, right? And then basically what I do is that whenever I see a new number, I push that number and negative infinity to the stack. I'm just going to put 8 for like an infinity. Fine. Okay, there you go. And then when I see a next number, then I check and I update either the top, because now the top represents the number, the range of numbers that we want to look at, right? And now it's updated to 9, between 9 and 100. And that's kind of how I thought about it. And then now when we process a new number, 30, well, 30 is a new low. So that means that we actually want to push on the stack a 30 negative infinity as a new number, because this 100, like because we have a new min, the previous max doesn't matter anymore, right? Because there's, getting a number between 30 and 100 doesn't mean anything in this case, right? And then when you can see a 70, we get 70 and so forth. And then this is the ... So that's kind of the logic that I was playing with. I think the case that I was actually going with was like 1, 2, 3, 4, 5. or something like that, and then you have a 1, negative infinity, and you put in a 2, and then oops, and then you see a 3, which is not a new min, so you ignore it, and then 4, you also, it's not a new min, so you ignore it. And oh no, well, 3 is not a new min, but it's a new max, so you update this to new max, new max, new max, right? Or if you have the other way where 5, 4, 3, 2, 1. Oh, I also, so you have a 5, negative infinity, 4, negative infinity, and so forth, right? Also, actually, I forgot that. I also mentioned that sometimes you have to look for the inverse of what you want. So that means that instead of looking for a 1, 3, 2 pattern, maybe you try to find where this pattern cannot exist. And sometimes that's the way to solve this problem, but that's not the case to solve this problem, because I was playing around with the idea of like, okay, well, if it's sorted, it's definitely false, and if it's in reverse order, that's also false, right? But that's not enough, because, for example, if you have a case like 3, 1, 2, then this is not this is not sorted or opposite, or like sorted descendingly, but it still doesn't have the pattern, right? So then I was like, okay, but that would be in linear, you know, maybe some, you know, that would be in linear time, because you just, you know, but that didn't work. So basically what I did was that for each of these things, I kind of, and it's a shame that we don't have that video, but basically I just play with different combination of possibilities, meaning that I just, here, I created, you know, I started with a stack and I go, okay, what are the possible next inputs, right? Well, first of all, let's say this is, you know, if this is 50, let's say this is between the last stack, well, then we just return true. So that's trivially done. Let's say this is higher. Let's say this is 90. As we said before, if this is just 90, we update this to 90, and then we, you know, and then we have the same state, right? Kind of, right? So basically, those are the two other cases. Those are the two cases, right? And then now we talk about min. So what happens? Well, we have a min, so we just add 1 as a min, and then we kind of go through here the different cases, right? So then the next number, let's say if it's another min, so this is min, negative infinity. Let's say if it's another min, then we just have like another min, right? So, you know, like negative, I don't know, let's just say it's 0, negative infinity, so forth, right? But this is essentially the same thing as 1, negative infinity. So, so we can ignore it per se. Yeah. Right. But now let's say we have next number here is a number that's between, let's say we have 35, right? Which is what I hear. It's a little bit smaller, but well, 35, you put in a 35, so you update the max here, but then you want to keep track of, well, what happens, right? Can you combine more items, right? So that's what I was going through when I was coding it. I was like, okay, we were able to do it one step at a time, but is there some kind of relationship that allow us to combine the intervals, if you will, right? Because, for example, if you don't combine them, let's say you have this number, this sequence, and I kind of created this on the spot trying to figure out a test case, right? In this case, if you add 95, well, 95 is clearly not between 30 and 70. So if you just update this to 95, well then, and you call it being done, that's not good enough, because 95 is clearly between 90 and 100, right? So we have to do something that allow us to kind of iterate backwards and looking backwards and taking advantage of some invariant, right? And invariant is something that doesn't change as you go as other things change. I think I realized I'm talking really fast. I apologize for that. Definitely turn on the captions if you can, because I'm a native New Yorker, native English speaker, so I understand that some people may have trouble with me talking too fast. So I apologize. I try to talk slower. I didn't realize. But yeah, but let's say 35. So 35, as you look at the top of the stack, well, 35 is between 30 and 70, so we just return true. And then in other cases, let's say, well, let's say we have a number that's bigger than the previous one, right? Well, in that case, one to the range of 1 to 99 totally covers from 30 to 70, right? So that what does that mean? That means that if a number is between 30 and 70, it's also between 1 to 99. So then we can safely pop this off, right? And then the other one is what if the next number is smaller than 30? Well, we just push it to the stack and then we just kind of move on, right? And then there's the other scenario, kind of like, 40 and 99 or something, right? Not, but this is not a possible. This is not a possible state, because before that we would have 40 negative infinity maybe, but that won't even happen, because before that we have 40, and 40 would have been between 30 and 70, and that we would have returned true. So because of this invariant, we're able to kind of prove that that doesn't come up, right? So this is basically my code, and one cute thing is that this is why I hate kind of labeling things, and what I mean by that is that looking back, you could say, oh, this is a mono stack problem, right? Because if you look at the stack, the min property of the stack will be monotonically decreasing, because if you look at it as a prefix min kind of thing, you only push it to the stack if the incoming number is smaller than the previous min, right? So by definition, it's monotonically decreasing. So you could call it a mono stack, but that doesn't help anything. That doesn't use anything. So I think that's like, that's not very helpful, right? Even though you could call it a mono stack and you could sound really cool doing it, but it's not, that's not helpful for this problem. And you can note that up until now, I did not mention monostack once, and that's a property that we don't even need it to solve this problem. But basically that's all I have for this problem in terms, and we'll go in terms of explanation. We'll go over the code, which is that, well, if the stack has no items, we push an x in negative infinity. If it's smaller, we push it on top, as we talk about, like if it's, if the current item is smaller than the min, we create another min. Otherwise, we look at the previous min, and this min that's on top will always be the min going backwards, right? As we talked about before, because if it's monotonically decreasing going forward, then it's monotonically increasing going backwards, right? So that means that we can just look at the max number, and as soon as that this is greater than max, we know that the min is smaller than their min. So we just have to check that the max is bigger than the max, so that this is this case, pretty much. And we do a while loop because as it keeps happening, we can keep on removing segments that we don't need anyway, because we'll never need to check it, because if they're both getting covered, then we could we could keep on removing it. And that's what the while loop is for. And then once this is done, we just check to see whether the new segment, before we push it to the stack, the last segment that we haven't, that isn't an overlap, we check to see whether x is inside that segment. And if it is, then we return true. If at the very end we still haven't found any case, then we return false. It's a little bit complicated, a little bit tricky, and to be honest, it took me a good amount of time solving this, which is really annoying that I lost the video. But yeah, so what is the running time complexity of this? Well, for each element in nums, we either push it on the stack once or we pop it off the stack once, right? So that means that overall it's going to be linear time, because there's n elements. Each element does about O of 1 work, so it's O of n time, which is linear time. And because we do a stack and we could push every number on the stack, that means that it's going to be linear space. So linear time, linear space. That's all I have for this problem. Let me know what you think. Definitely, if you have questions, let me know. I will try to answer them. And it's something that not only will I answer these questions like for this video, but I try to answer it in the future as well, because now that I'm aware of people are thinking about it. So definitely would appreciate it. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think, and I will see y'all tomorrow. Bye bye.